Hello everyone, this is from Earthscience Classes. Now we are going to discuss regarding a concept of atmospheric atmospheric science or climatology, that is atmospheric instability. So here we are going to discuss regarding three concepts: absolute stability, absolute instability and conditional stability. So before going to that, I will introduce some of the terms so that you can understand in better way. So first thing is lapse rate, air parcel, environment, saturation. Saturation of air parcel. So starting with what is air parcel? First of all, let's discuss what is air parcel. So air parcel is something different than environment. Air parcel is a closed thermodynamic system. Let's say this is our atmosphere. We are considering air parcel, that means a closed thermodynamic system on which we are applying our thermodynamic parameters like temperature and pressure. This air parcel, either it is rising off, and when it rises off, the temperature decreases. The temperature decreases because in higher altitude the temperature will decrease. The pressure will also decrease on the air parcel. The pressure on the air parcel will also decrease, because talking about atmosphere, if we are going with higher altitude, if we are increasing with higher altitude, what happens? The pressure decreases. The atmospheric molecules or the concentration of atmospheric molecules, that are also decreases. So the atmospheric pressure also decreases as we are moving with higher altitude. Talking about different layers of Earth's atmosphere like troposphere, stratosphere, mesosphere and exosphere, anything. So if we are going from the surface towards higher altitude, the pressure will also decrease due to decrease in concentration of atmospheric molecules. The temperature will also decrease because the temperature will decrease with higher altitude. So when the air parcel is moving off, what happens? Its temperature decrease, pressure on it decrease. That's why the volume will increase. The volume will increase because when the pressure will decrease, it will expand. When the pressure will decrease on the air parcel, the volume will expand for the air parcel. Talking about when the air parcel descends down, that means it decreases with altitude. That means it is coming towards the surface. Its temperature increases because the near surface is having higher temperature as compared to higher altitude. The atmospheric pressure increases. That's why its volume decreases. So these are the properties of air parcel. When it is ascending, its temperature decrease, pressure decrease on it, so volume expands. When it descends, its temperature increase, pressure increase, so volume the volume will decrease on the air of the air parcel. Then talking about environment, as I have told you, air parcel is the closed thermodynamic system. Anything other than it in the atmosphere, that is considered as environment. That means the atmosphere surrounding the air parcel is termed as environment. The properties of the air parcel that differs from the environmental properties like temperature and pressure. So that difference will lead to these conditions like stability or instability. Then talking about lapse rate. So as I have told you, when air parcel rise in the atmosphere, its temperature decrease. When air parcel rise in the atmosphere, that is altitude increase, there is decrease of temperature. The rate of temperature with increase in altitude, the rate of decrease in temperature, rate of decrease in temperature with increase in altitude, that is termed as atmospheric lapse rate. When the temperature decreases with altitude, that is positive lapse rate. When the temperature increases with latitude, with altitude, the lapse rate is negative. Okay. So talking about different layers of atmosphere, talking about troposphere, if we are moving up towards the upper atmosphere from the surface, the altitude will increase but the temperature will decrease. In that case, that is positive lapse rate. When we are going for stratosphere, with increase in height, the temperature will increase. So in that case, that is negative lapse rate. So the lapse rate will also have a role in this stability and instability. Then talking about saturation. what is saturation? Saturation of air parcel. To be saturated air parcel, an air parcel to be saturated, it must have 100% relative humidity. 100% relative humidity. Then going to what is relative humidity? Relative humidity is absolute moisture content, absolute moisture content divided by saturation vapor pressure. Absolute vapor pressure or absolute moisture content divided by saturation vapor pressure. So what is absolute vapor pressure? That means the total amount of moisture content in the air parcel at present. That is your absolute moisture content or absolute vapor pressure. Talking about saturation vapor pressure, that is constant for a temperature. This saturation vapor pressure will have a constant vapor pressure at, let's say, T is certain temperature. At that temperature the saturation vapor pressure will be constant. Let's say 30 degree. For example, if the air parcel is having 60 gram moisture, then that will become saturated. That means at 30 degree, if it becomes 60 gram vapor pressure, if it will contain 60 gram vapor moisture, then we will term it as saturated. So in that case, the saturation vapor pressure at 30 degree is equal to absolute moisture. That means at 30 degree temperature, it is containing 60 gram vapor and it is required 60 gram to be saturated. That is your saturation vapor pressure is equal to absolute humidity and into 100. Relative humidity is calculated in percentage. So the relative humidity will become 100% in that case. For example, let's say an air parcel near surface, it is our surface, it is having a temperature of 30 degrees centigrade, it is having a temperature of 30 degrees centigrade and containing moisture of 40 gram. So here the absolute vapor pressure is 40 gram, saturation vapor pressure is 60 gram. So if we calculate the relative humidity, that will be 40 divided by 60 into 100. That will be anything. So the relative humidity that gives you the that amount of water vapor needed for the for the air parcel to be saturated. Relative humidity that doesn't suggest how much vapor is within the air now. It is suggesting what much is required to be saturated, right? So it will show you how much percentage it will require more to get saturated. So when the relative humidity becomes 100%, the air saturated. So that leads in two conditions: either the temperature will decrease or the vapor will increase. Either we have to decrease the temperature, that means the air parcel now it is having 30 degree centigrade temperature and containing 40 gram water vapor. Okay, I have already told you, let's for example at 30 degree centigrade temperature it will be saturated if vapor pressure will be 60 gram. So let's increase more 20 gram water vapor, or if I will decrease, let's say at 20 degree centigrade temperature the air parcel will saturated at 40 gram water vapor. At 20 degree centigrade temperature, if it will contain 40 gram water vapor, then it will become saturated. So let's decrease the temperature to 20 degree centigrade. As I have already told you, if the air parcel will become 100% relative humid, then it will become saturated. That means either I have to increase this value, absolute moisture content, what I have told you, to add 20 gram, or I have to decrease saturation vapor pressure, or I have to decrease saturation vapor pressure. How to decrease saturation vapor pressure? Just decrease the temperature, because saturation vapor pressure is directly proportional to temperature. As I have told you, there is a fixed amount of moisture content, at certain temperature for which the air will become saturated. As for example, I have given here 30 degree, 60 gram, 20 degree, 40 gram. So if I will raise the air parcel to upper atmosphere, if the air parcel is raised to upper atmosphere, what happens? Its temperature decreases. So near surface it is having a temperature of 30 degrees centigrade. If it will rise at certain height, what happens? It will attain the temperature of 20 degrees centigrade. Got that? at 30 degrees centigrade it is containing 40 gram water vapor. When the air parcel will rise to upper atmosphere, its temperature will decrease. As I have told you that with increase in altitude the air parcel decreases the temperature. So at certain height what happens? It will have that temperature 20 degrees centigrade, and we have already known that at 20 degrees centigrade the saturation vapor pressure is 40 gram. So at that point of time the air parcel will become saturated with that much vapor content. I am not adding any additional vapor, but I am just decreasing the temperature. At certain altitude it will become saturated. That happens in natural case, but most of us think that when the air parcel will become 0 degree it is getting saturated. No. When the temperature become 20 degree it can also saturated. At 40 degree temperature also it can saturated. At minus 4 degree also it can get saturated. So that depends upon the absolute moisture content and saturation vapor pressure at that particular temperature. So that will lead to 100% relative humidity and that will lead to saturation. Next thing is precipitation. Precipitation can take in many forms like rain, snow or hailstone, anything. But that precipitation doesn't take place when the air becomes saturated. It doesn't mean that the air gets saturated then there will be precipitation after that point of time, because the raindrop should be of greater size. After saturation the raindrop will grow in size. We will go to that concept in form of precipitation and different concepts of precipitation. But just after saturation it is not that that the air parcel will become or the air parcel will lead to precipitation. After saturation the moisture should grow to that much radius, so that it will becomes higher, that higher mass, it will become of higher mass, so that gravity will attract it and there will be precipitation. After saturation there will be growth in size, then there is precipitation. It doesn't mean when air will become 100% relative humid then it will get precipitated. Okay. So these are some of the fundamental concepts. Now I am starting with the different conditions, that is absolute stability, instability and conditional stability. So starting with first one, absolute stability. First of all, what is the condition of stability? See, as I have told you, air parcel is a thermodynamic system, closed thermodynamic system, and the surrounding is its environment. When air parcel will have temperature less than the surrounding, then the air parcel is stable. When air parcel will have temperature greater than the surrounding or environment, then that will become unstable. Because when the air parcel will have greater temperature, there is increase in entropy. There is increase in entropy. So what happens? The air will become loose. The air will become loose as compared to its surrounding. See, it is the atmosphere at a certain altitude, let's say 30 meter height, This is our closed thermodynamic system I am talking about, that is air parcel. It is having certain temperature which is greater than the air surrounding it, which is greater than the temperature of the environment. So what happens? It will become loose, so that it will tend to move upward because there is increase in buoyancy. So what is buoyancy? Buoyancy means upward rising force or upward raising force, that is from inside of the air parcel. Because it becomes loose as compared to its surrounding, it will tend to move upward. It will tend to move to the higher altitude. So when T1 is less than T2, that means temperature of air parcel is greater than the temperature of environment. Temperature of air parcel will be greater than temperature of environment. It will become loose and it will start to move upward. In that case, it will develop vertically developed clouds. Vertically developed clouds. For For example, different type of clouds are there. For vertically developed clouds, let's say the examples are cumulus and cumulonimbus. These two clouds are vertically developed clouds and they occur in case of thunderstorms and other atmospheric events which are unstable, which are due to unstable atmospheric conditions. Thunderstorms never form when there is stable condition. Okay, that doesn't mean in stable atmosphere we are not getting rain. In stable atmosphere there is precipitation. There is precipitation. We are going to discuss how there will be precipitation. But in unstable atmosphere there is severe atmospheric conditions like thunderstorms and hurricanes, etc. Right. So in that case, they will lead to development of vertically developed clouds or cumulus or cumulonimbus clouds. Okay. Because of this growth, I'll show you the diagram in next. So now, starting the stability, you can see here, these are the condition of stability, let it be here. Now just take here, the lapse rate I have already told you, lapse rate is decrease in temperature with increase in altitude. Okay, now lapse rate I can divide into three types. One is atmospheric lapse rate or environmental lapse rate. That means, as I have told you, there is air parcel, there is environment. So the environmental lapse rate means the decrease of temperature of the environment. That is different from temperature of air parcel. Okay, when there is decrease of temperature of environment, we are naming it environmental lapse rate or atmospheric lapse rate. Then talking about air parcel, that is divided into two types, dry adiabatic lapse rate and wet adiabatic lapse rate, or that is moist adiabatic lapse rate. So what is dry adiabatic lapse rate? When the air is unsaturated, when the air parcel is unsaturated, the decrease in temperature is termed as dry adiabatic lapse rate. Dry means the air is unsaturated. When that is saturated, then we are terming it moist adiabatic or wet adiabatic lapse rate. When the air parcel will become saturated, that means 100% relative humidity, then we are terming it that it is moist adiabatic lapse rate. The decrease of temperature with height when the air becomes saturated is termed as moist adiabatic or wet adiabatic. The decrease of temperature of air parcel with increase in height when the air parcel is unsaturated, that is dry adiabatic lapse rate. The decrease of temperature of the environment or the surrounding environment, that is known as environmental lapse rate. So now we are going to derive the relation between these three lapse rate in defining whether that is absolute stability condition of atmosphere or instability or conditional stability. There are many questions, I think in every year there is asked in NET for the relation between these three. So let's see here. Here you can see this side it is environmental temperature. It is environmental temperature. You can see the air parcel near the surface that is having a temperature of 20 degrees centigrade. One more concept is when there is land surface, it can get easily heated. The land surface can get easily heated and the air parcel, they are poor conductor of heat. The air, not air parcel, the air or the atmosphere, those are poor conductor of heat. So the air near surface, the air which are near surface, that will have higher temperature, but the upper atmospheric air that will have lower temperature, because the heat cannot be transmitted through the air. So the air which is nearer to surface, that will have higher temperature as compared to the upper atmospheric air. So you can see here the air parcel which is nearer to the surface, that is having a temperature of 20 degrees centigrade. I am talking about environment, air parcel is different. So the environment is having 20 degrees centigrade here, and here the environmental lapse rate is taken as 5 degrees centigrade per kilometer. 5 degrees centigrade per kilometer means the temperature will decrease 5 degree with 1 kilometer altitude. So you can see here, near surface it is having 20 degree, at 1000 meter or 1 meter height it is having 15 degree, then 2000 meter 10 degree, 5, 0 and minus 5 like that. Then talking about air parcel, as I have told you, for air parcel there is two types of lapse rate, dry adiabatic lapse rate when it is unsaturated, then wet adiabatic lapse rate. So see, when dry adiabatic lapse rate is higher than wet adiabatic, it is the condition which remain always constant, that the dry adiabatic lapse rate should be higher than the wet adiabatic lapse rate. Taking an example, when we are boiling water with a pot, if we are only heating the pot without any water, if we are heating the pot without any water, what happens? The temperature will rise with a faster rate. If we are letting it cool, then it will cool down with a faster rate. But if there is water inside that pot, the temperature will rise slowly, and if we are cooling it, the temperature will down also slowly. Okay, so when the air is dry, it is unsaturated, then what happens? It will decrease the temperature with faster rate or increase the temperature with faster rate. When that is moist or saturated, the temperature will decrease slowly as compared to when it is dry. Okay, so you can see, when the air is unsaturated near surface, as I have told you in previous case, that the air will become saturated. When it rises up, it will decrease temperature, so the saturation vapor pressure will decrease, then it will become condense, then it will condense and then will become saturated. Okay, so when it is near surface, it is unsaturated. As I have told you, let's say it is having 20 degree centigrade temperature in near surface and it is containing 20 gram water vapor. For example, it is containing 20 gram water vapor. When it reaches 0 degree centigrade, as I have already mentioned you, that it is not that when it reaches 0 degree it will become condensed. Okay, the temperature can be 20 degree, 30 degree, anything. When it contains that much of water vapor to be saturated, then we are naming it saturated air parcel. That doesn't mean when it attains 0 degree. In this diagram, it is taken 0 degree, that's a coincidence. Okay, so you can say here that air parcel which is nearer to surface, that is having a temperature of 20 degree centigrade. When it rises off, it will have 10 degree centigrade. That means the dry adiabatic lapse rate is 10 degree centigrade per kilometer. The air parcel is unsaturated here, so it is 10 degree centigrade per kilometer, the dry adiabatic lapse rate. It is decreasing 10 degree centigrade temperature with increase in 1 kilometer height. Then after next 1 kilometer, it will decrease to 0 degree centigrade, and at that temperature it will be saturated with that much amount, 20 gram water vapor. At 20 gram water vapor, it can get saturated at that temperature. So that is your boundary line, or that is your altitude at which the dry adiabatic lapse rate now changing to wet adiabatic lapse rate. Till here, this is for unsaturated. This region is for unsaturated air parcel. Now we are considering for saturated. So here we are using dry adiabatic lapse rate, and here we are using moist adiabatic lapse rate. Okay, that is almost constant for every air parcel. Dry adiabatic lapse rate is 10 degree centigrade per kilometer, and wet adiabatic is 6 degree centigrade. Let me see, yes, that is 6 degree centigrade per kilometer. So what happens after condensation? You can see the cloud only form when there is condensation. After saturation only the air lead to formation of cloud. In unsaturated air parcel, cloud development is impossible. Okay, so at 0 degree centigrade, when it attains saturation with that much vapor content which is nearer the surface, same thing, okay, same amount of water vapor, but decrease in temperature lead to decrease in saturation vapor pressure, so it will become saturated here. Then we are applying the moist adiabatic lapse rate, that means 6 degree centigrade per kilometer. Then after this height, when it increase 1 kilometer height, the temperature will decrease by 6 degree centigrade. The temperature will decrease by 6 degree centigrade. You can see in the previous case that is decreasing 10 degree, now it is decreasing 6 degree. Then above 1 kilometer again it will have the temperature minus 12 degree, again minus 18 degree. Okay, so that is decrease in temperature with height. We have considered dry adiabatic, wet adiabatic and environmental lapse rate. Okay, now see the relation between these three. So you can see here the environment at zero height, near surface means zero altitude, it is having a temperature of 20 degrees centigrade. That means the environment means surrounding, and the air parcel is having that temperature 20 degrees centigrade. At 1 kilometer height, the air parcel is having temperature of 10 degrees centigrade and the environment is of 15 degrees centigrade. That means environment is having higher temperature than the air parcel. In 2 kilometer altitude, the air parcel is having 10 degrees centigrade, sorry, the atmosphere is having 10 degrees centigrade temperature and the air parcel is having 0 degrees centigrade temperature. So here also environment is having greater temperature than the air parcel. When we are going to 3 kilometer altitude, here it is also same condition, environment is having greater temperature than the air parcel. It is having 5 degree, the environment is having 5 degree and the air parcel is containing minus 6 degree centigrade temperature. In every altitude, at every altitude you can see that